All right, running through 4 more examples here. Again, the idea is to go from polar, where I have this r and theta coordinate system, into a more comfortable xy coordinate system. So same thing for all of these. I'm going to need r cosine theta, that will get me my x coordinate, and r sine theta, that will get me my y coordinate. So I wind up using that r value twice. Our r is kind of gross here, -1/4. It's going to be okay. And then I want cosine of my angle and sine of my angle. So my angle is also negative in this case. If we jump back to our unit circle here, I have a negative angle, so I want to go clockwise around the unit circle. So we're going to be talking about this angle. -pi/2 is coterminal with 3pi/2. So my my cosine value is 0. My y value will be -1. So going back to the original problem here, get a 0 and a -1. So not as bad as it could have been. Anything times 0, that's just 0. Goodbye. And then negative times a negative will make this y coordinate a +1/4. Let's do another one. Number 4 here, back to a nice positive number. Very nice. Oh, but then we had a negative angle. Sad day. Oh, substituting in our values then. R will be 7. So keep in mind you need that R value for both cosine and sine. And now in my unit circle, I'm looking up -5pi/6. 5pi/6. Positive would be right here, but I want a negative angle. So it will be right here. If you're having trouble with those negative values, you can always just use a bit of counting to help you out. This is 1pi/6. This is 2pi/6. This is 3pi/6. 4pi/6. 5pi/6. 6pi/6. Except I didn't need 6. I wanted -5pi/6, so there's 5 of those slices of pi there. And that gets me coterminal with 7pi/6. So you can always use a counting strategy to help you out there. You can also find coterminal angles through arithmetic. -5pi/6 plus 2pi gets you to 7pi/6. There are several other strategies to help you if those negative angles are still causing you a bit of grief. Keep in mind what we want out of this are the cosine and sine values. So the -√3/2 and the -1/2. So stealing those away. It was -√3/2 and -1/2. So this point isn't going to be quite as nice as the previous ones. Nothing cancels, so 7 times -√3/2 is just -7√3/2. Likewise, we get a -7/2 for the y coordinate. Not every point will be pretty. So what happens when we have degrees? Sometimes playing around with degrees is really nice. It's something we like. And other times it's kind of like, oh, this thing again. So I'm going to pause real quick, pull up a calculator.